Hello, and welcome to our introduction to linear momentum. Now, linear momentum, right off the bat, that word linear tells us that it's an adjective and suggests then that there are other adjectives and there are other types of momentum. It turns out there are other types of momentum, including rotational momentum, which we will learn about a little bit later in the course. So, linear momentum specifically applies to motion in a line in one dimension. Now, the formula for linear momentum is P equals m times v. Now, v we recognize as velocity, and that has units of meters per second. Mass has units of kilograms, not grams. So, coming out of chemistry, mass was in grams. In physics, mass is measured in kilograms. And it's the only one of the units we use in physics that always has a metric prefix with it. So it's the only one where there's a kilo. And so again, this is mass, it's not weight. And in this course and in physics, every single person should know that 1 kilogram equals 2.200, and it keeps going in terms of significant digits, pounds. On Earth, whose symbol is this, at sea level. So that's a conversion you should know, so you can use dimensional analysis to convert from pounds to kilograms for things on the Earth. Now, of course, since we're putting qualifiers on this, and we are presaging what we will learn a little bit later in the course, so by saying that it's on Earth, that means it's different elsewhere. And we're saying at sea level, it means it's different elsewhere other than sea level as well. So these are our units. Those are the formulas, or the two quantities on the right-hand side. And then we have momentum, which is given as P. Now, some folks wonder why is it P? Why isn't it M? Well, some people would argue that there would be two M's in the same formula. And that would be true, but that's not the real reason. The real reason is that the concept of momentum comes from this word, several words in Latin and Greek, impetus. So for Latin, it means in plus petera, which means to go to or seek. So if something has momentum, it is seeking to go somewhere. If something has inertia, it wants to keep moving, like it has a goal in its mind to get there. And similarly, in Greek, it's the pedestai, which means to fly or tear on wing. And of course, we say we might take flight or to fly away. Doesn't necessarily mean we fly like a bird. It means we move away from or go towards something flying. And so that's why it's P for momentum. Now that means then that if m is kilograms and velocity is meters per second, that means that the units of momentum are kilogram meters per second. And we say it this way: kilogram meters per second. And so we could write this as kg ms to the minus 1. If we wanted, we can write it as kilogram meters per second, either way. But that is the formula, and those are the units. Now, momentum is a vector quantity, so P equals mv. Well, we know v, velocity, is a vector. So v is a vector quantity, and m is a scalar. And it turns out that momentum is also a vector, which means we could have positive momentum or negative momentum. So if we were to have a number line like this, or positive and negative, and we had a body moving in this direction, we know that its velocity is positive, and therefore the momentum is positive. Similarly, if we have a body headed in that direction, the velocity is negative, therefore the momentum is negative. So whatever the sign of the velocity is, so too is the sign of momentum. So I want to do just a little bit of an exercise here. It's an exercise in momentum and in estimation. So we have a high school student who's about to cross the finish line running the 100 meters. Well, let's go about estimating her momentum. Let's estimate her momentum. And so what I'd like you to do is to pause the video here and see what value of momentum you would come up with. All right, so now that you have paused and gotten submitted your answer, I am going to start off with the formula P equals mv. And since I'm looking for an estimate, I first want to get a sense of what her mass would be. Now, when I don't know the value of something, I can just pick a number and ask myself if the real value is more or less. So let's say if we have a high school student and she is running the 100 meters, is it likely she weighs 1 pound? Of course not. We know that's way too light. What about 10 pounds? That's also way too light. What about 100 pounds? Now we're getting closer. And if we went to 1,000 pounds, we know that is way, way too much. So we're looking at somewhere between 100 and 1,000. We could go to 200 pounds. Well, we know that's too much. And if we go to 150 pounds, that is probably also too much. And so we might land at about 120 pounds. So notice how we were able to get a ballpark picture, a ballpark snapshot, or an estimate of her size. So now we know that it's 120 pounds. We can multiply by our conversion factor, which is 1.0 kilograms, is 2.200 pounds. Pounds cancel. We're going to be left with kilograms, and that leaves us with about 45 kilograms. So we know the mass is 45 kilograms. Okay, great. Now what about the velocity? All right, well, we could do a similar thing. Let's start out with the velocity and pick a number. Well, is it likely to be 1 second? No, not enough. 10 seconds. That's super fast. That's world record speed. What about 100 seconds? Well, that's more than a minute. That's definitely not the case. So now we could go to 50 seconds. 50 seconds, that's still too long. Someone really, really fast would run almost a full lap around the track in that period of time. What about 25 seconds? Probably a little bit slow. 20 seconds is more reasonable, and maybe 15 seconds would be reasonable. But we can just settle in then on about 15 to 20 seconds. So we put that 20 seconds in there, and then we find out that her momentum is 900 kilogram meters per second. So it's very simple to plug in numbers if we have them. We took it up a little notch here to go about how we might estimate that value. So in this case, we would say her linear momentum is 900 kilogram meters per second. And so that concludes our introduction to linear momentum, its formula and a basic calculation. In the next short lesson, we are going to take a look at momentum definitions and relationships. See you soon.